Hi folks, I would like to create a video segment on several different ways of solving the problem that you see right in front of you. It's a cantilever beam that is loaded with a point load at exactly halfway point, okay? Now if this was loaded at the tip in Catia, it would be very easy to model it. But if it's loaded somewhere in the middle, somewhere along the way, for example, right at the midpoint, there are some subtle issues that one should be considering. So it's going to be done three ways, and you have to be patient because it's not quite clear why I'm doing it this way, but you'll see. The dimensions that I'm using are here. The length of the beam is 10 inches. The cross section is circular with a radius 0.5, and I have used this formula from Hebler to calculate the tip deflection due to this loading, and the load is 200 pounds. Okay, let me do it the first way. The first way is creating two lines, or let's put it this way: either two lines or a sketch made of two line segments, each one 5-inch long. So let me go to Catia right here, and on a convenient plane, on that vertical plane, I will sketch. All right, sketch two line segments, each 5 inches long. So here, this is the first one. Okay, then another one starting at this end and going there. Let's give them each 5-inch dimensions. So this one is 5 inches, and the other one is also 5 inches. Notice that I insisted on making two line segments, but of course they have a common point, which is right there, as you can see, right at that halfway point. Exit. Okay. So you see this little white dot here is because these two line segments are not, are basically meeting at that location. Now, the next thing is to join them, as in the past. So the joining process is in wireframe and surface design. You can go to mechanical design, wireframe and surface design, or you can go to shape and generative shape design, and in both cases you'll have the joint icon. I will take you to the mechanical design, wireframe and surface design. The main reason that I go there is that the majority of the problems dealing with shells and beams, I do the wireframe and surface design, which is the simplified or the limited version of that generative shape design. So right there, you see that? Join. Under the operations toolbar, there's the join, and you select the sketch and you say OK. So all it does is it joins these things because that's needed in order for us to be able to mesh these this object. Now let us go and apply material to this. We can do it right here. We don't have to go to part design. So metal, and I'm going to choose steel. On the part, and incidentally, because I want to compare it with the same exact values that I had in this MathCAD worksheet, so I'm going to change the Young's modulus of it. So let me double click on the steel. Just give it a second. The dialog box is going to open up, and you select the analysis, and notice that the Young's modulus, as it is, it's 29.01 times 10 to the 6. So because in my MathCAD worksheet I say 3, so I'll make it 3, and we close this. All right, good. Now the next thing is to go to generative structure analysis. Okay, and then we are doing a static analysis. We have to mesh this thing. So let's see now, where is the beam measure is right here. You select this, and right now it says element size is 0.1. So okay, in other words, this is going to be divided into 50 pieces, and this is another 50 pieces. That's 100. We can make it 1. Okay. All right. Can make it 1, and we can actually look at our mesh. So we have 5 elements here, as you can see, and 5 elements there, and at there is a common point, common node right there. You can see that there is a node 2 is exactly halfway in the middle. Okay, now deactivate this, deactivate that. Okay, and now let's see now the cross section. Make it select this. It is circular, and the radius is 0.5 according to my MathCAD worksheet. Okay, and then because it's the cross section is circled, you don't have to select an orientation point, and you can just close this. Okay, and what else do we have? We have this end is clamped, means no translations, no rotations, and we have a point, a 200-pound point right there at that node. So, or at that point actually, this junction point is right there. So we say force at this vertex. The vertex can be picked, and you can see that it actually puts it there. And the value is negative 200 pound lbf. Okay, good. We can run it now. Why don't we do this property? So file, save management, save as. Actually, let me cancel that. Select the analysis, save as, and on the desktop, new folder, and I will call it beam bending. Beam bending 3 ways, 3 different ways. Okay, so let's go ahead and save the analysis. Automatically it's going to save the part in that location. Now let's run it. And look at the displacement value, and right there, see that? The maximum deflection, which is at this tip point in the Z direction, is 0.0143 downward, and this is the MathCAD value. So obviously this thing worked. I just want to point out to you, some of you may occur that, oh, could I not have taken that that entire line? The answer is yes, you can. You could have, except that it's not going to be a concentrated force anymore. It's going to be almost a distributed force from one end of the beam to the other end. Of course, the answers are going to be different. Okay, so this was the first way of doing it. Now, let me close this. I'm done here. And I'm going to close that. Let's do it the second way. The second way is the following. So let's start with the part file. Right there. Okay. So I'm going to create a sketch once again. So on that vertical plane, I will draw a line 10 inches long this time. Right there. 10 inches long. Let's make that thing actually 10 inches. Good. Exit. Exit. And join it. Let's apply material to it. where is that? Metal, steel, on that part. You say OK, and if you want to change the value so that it's exactly the same Young's modulus, just do it like this. We select it, and then we say 3 e to the 7 psi. Okay, good. Now, I am going to create a point which is, let's say, I'm going to create a point with coordinates 0, let's see now, 0, 5, 0. So a point coordinate 0, 5, 0 right there. Now this point, although it seems that it's on that line, but it is not. It's just that line, that sketch, and this point, they have nothing to do with each other. Okay, good. So the next thing is you go to, again, you go to, okay, now this time, don't go to generative structure analysis. Go to this advanced meshing tool. Now, I've never taken you in class at this point in the course to this advanced meshing tool, although I warned you that there are many places in the book that it goes there, and I will talk about it later on in the class. So, advanced meshing tools, static analysis, okay. Now here's the beam measure. You see that? This is all unfamiliar to you. There are no, there are no places where you can apply the load and restraints and things like that. Advanced meshing tool deals only with mesh. So you click on the beam measure. Notice that there is more options that you have here than the beam measure that you had in the generative structure analysis. Like these things were not present before. So here's the situation. First of all, let's select the line. But down here, you see that down here, there is this icon which says add isolated point. In other words, I have a point which is not on that mesh, not on that line, but I would like to include that to be part of that mesh basically. So you select this icon right there. See that? Select the icon. It says within the tolerance, some specified tolerance. So I'm going to select that point, and you say OK. All right. Notice that now that point is related, will be related to the mesh that we have created here. And you say OK. The rest of it is exactly like before. In other words, to apply the restraint and the load and things like that, you have to go to generative structure analysis. There is no ifs and buts. Okay, so you go there, and let's apply our first of all apply our clamp. There's a clamp here at this end. Okay, and apply our load to that point. See this? If you just created the point without doing the trick that I you use that icon and projected basically that over this, you can apply the load, but it will not see it. Try it please on yourself. In other words, repeat this thing, but do not go to advanced meshing tool to include that point. Just try to do exactly what I did. You'll see that this load that you put here will not affect the beam deflection at all, because yeah, just try it. Now, the only thing that I have to do is the cross section of the beam, which is this. It's exactly the same thing that we had before. Way up, 0.5, and we're gonna run it. And look at the deflection, 0.0143. Okay. Now, just to convince you that if you repeat this without going to the generative, without going to advanced meshing tool, I will repeat it, but you see that it's not going to work. This is okay because I went to advanced meshing tool, I made sure that point that I created was actually projected into the line, and therefore it worked. So just to convince you that otherwise it won't, so let me close this, close that, go back here, right there, see that? Here's the point, here's the line. So now go to convince you that it's not working. If I don't do it like that, we already have the material and everything. So you go to generative structure analysis, okay, and here's the beam measure. Notice that it doesn't have that stuff that was underneath this this dialog box. So you select this, mesh it, no problem, and now clamp. What is that? Clamp this point. Apply a force to that point, and you will see that it's not going to work. In other words, everything looks good except that it will not take the load into account. And what is the cross section? Right there, just like before. Now if I run it, you see you're going to get zero deflection. That's okay. Something is missing here. Let me see now. Yeah, that's this is the reason. It's not going to work. You can see that. Okay, let's see this. No mesh element associated with the support of distributed force. It just doesn't work. Okay, so good. So the third method. This was just to convince you that something goes wrong. Okay, so let me close this, and the third approach will be the following. Let me start all over. Okay, good. So let's start with the part file. Okay, so I'm going to create two lines. I'm not going to do it as a sketch, but create two lines. So let's do it like this. So let me create 3 points. Okay, this is at the origin right there. Another one 5 inches away, so 5 inches away right there. And another one 10 inches away. 10 inches away. Okay, now let me create lines. One line that goes from here to there, okay, and another line that goes from here to here. All right, very good. Now these are not sketches. These are two lines that I created. Okay, so the next thing we're going to do, we're going to apply. We're going to apply material to this, just like before. Steel on that part, and we say OK. All right, and now we're going to go to generative structure analysis. Okay, first we mesh this guy. You see that? Now, because these are wireframe, these are not sketches, I did not have to join. You say OK, and then we mesh the other one, and it works. So we can look. This is the first piece, you can see that. Okay, and this is the other one. All right. So I have one mesh for the first piece, the other one mesh for the second piece. Deactivate these. Okay. Now, cross section. Circle, radius 0.5. Another one over here. Again, circular, cross section, radius 0.5. Now, these 2 points, if I hide this point, I'm going to hide this point for a second to show you what's going on. Hide it. And also hide this. In fact, I'm going to hide all my points. I have a reason I want to do this thing. Let me show you the mesh one more time. So activate the mesh. What I want to show you is that at the interface, there are two different nodes. So on this side, node number 8. On the other side, node number 1. So somehow I have to tell the software later on that node number 1 from the left side is the same as node number 8 from the right side. Okay? All right, so let me deactivate this. Deactivate this for a second. Deactivate. Okay. Now let's apply our clamp. Or is the clamp? Oh, right there. To this. Make sure you hide the point and you apply it to the vertex. See? The point was hidden. If I had applied the clamp to that point, not the vertex, you would have run into problem, just like we did a few minutes ago. You say, okay. Now, how do I tell the software that node on this side is the same as the node on that side, because they have different node numbers? So this is where we're going to use what is called a connection analysis. We're going to do a lot of this thing later on when we do assemblies, okay? So I select this. It says the first component, okay, let me hide this. Let me hide this. The first component is the left end of this line. The second component, I take the other line. So first bring that into the show mode. Put this in the hide mode. And this is the point. Okay, so I created the connection between 2 points. And let me bring this thing back. Okay, and I'm going to declare that connection as rigid. So the question is, where is that? We're going to see a lot of these things later on with assemblies, as I pointed out. But where is the rigid connection? So right there. It says distance. This has connection property. The first one is rigid. So I'm going to select this connection. If I have a hard time getting it from here, no problem. Get it from the tree. Okay. So this means that these 2 points are rigidly connected. Node 8 and node 1 are rigidly connected. And we can apply we already have the clamp there. We can apply a force to that point. And it doesn't matter which one, actually it's not really a point now. It's a node. Doesn't matter which one you pick. You'll put it there. And if you run this thing, hopefully we're going to get the same thing, same deflection. So run it. .014. Okay, 8. I understand that. But it's, so look, it's not that straightforward. If the place where the load is applied is somewhere in the middle of your geometry. If it's one of the edges, or it's one of the vertices, or you know, a face, there's no problem. But not if it's a point, you know, somewhere in your model. Okay, guys.